Can you repeat please your question, Karen?
ايه حتى غلط بالكويستشن. جاكوبي مع اوفر ريلاكسيشن انه ما لها عازه.
لا look هي بس تكون diagonally dominant، مش انه جاكوبي مع العازة، بس جاس سايدل بتكون احسن. اوكي، لانه انت بس يكون عندك سيستم اكيد انه convergent، جاس سايدل اسرع من جاكوبي. يعني عادة جاكوبي is recommended إذا convergence is not guaranteed، يعني إذا منك أكيد إنه it will be convergent. يمكن جاس سايدل تعطيك faster convergent، بس إذا في risk of divergence بيكون الريسك higher because سايدل من جاكوبي. جاكوبي is safer إذا system is prone to divergence، لأنه it's not updating values within the same iteration. يعني in general okay Jacobi is recommended is I am not sure of convergence أو إذا my system is prone to divergence. So if my system is prone to divergence I can expect إنه جاكوبي حتخفف هال compared to Gauss Seidel it's better، لأنه إذا بدك ما هيدا نوع كمان من under relaxation بغير معنى، لأنه الجاس سايدل update the values within the same iteration، بينما جاكوبي from iteration to iteration يعني بتأخر الابديت. So Jacobi when the system is prone to divergence Jacobi is recommended over Gauss Seidel. وزيادة عن هيك إذا استعملنا جاكوبي وضل divergent we can recommend to do under relaxation. يعني when the system is prone to divergence it's recommended to use Jacobi and under relaxation. وبرضه يمكن ما اوصل لسوليوشن، بس انه I can try this. Okay, while if my system is diagonally dominant يعني I'm sure it's converging ساعتها I recommend to use Gauss Seidel and over relaxation. Okay, plus over relaxation. بس all will work، يعني اكيد اذا كان convergent كارن جاكوبي كمان حتشتغل، واذا ما بتعملي اوفر ريلاكسيشن كمان حتزبط، واذا عملتي اندر ريلاكسيشن كمان حتزبط، بس بتصير عم بنطول السوليوشن على الفاضي لانه we are sure we will converge. So it will be a good idea then to over relax and to use Gauss Seidel. Okay,
Yes doctor.
any other question before we proceed?
دكتور يعني إذا السيستم منا guaranteed to converge نستعمل الجاكوبي، وإذا هي guaranteed to converge نستعمل جاس، ما هيك؟
اوكي هلا ليك sometimes مثل ما قلت لكم sometimes ما فيك تكون عارف من الأول، يعني هي إذا منا dominant مش يعني منا إنه منا منيح السيستم وما رح يعمل convergence. You should try، يعني in general you should try to know. اوكي بس إذا كنت عارف إنه هالسيستم يعني كيف بتعرف؟ عادة we know من الفيزيكس، يعني بدنا نعرف الفيزيكال situation اللي نحن فيها تنقدر نعرف إذا هالسيستم عنده divergence characteristics أو لا. إذا نحن بإنجينيرينج بروبلم وعندنا شك إنه معقول يكون في divergence ساعتها أحسن نستعمل جاكوبي. بس لو ما كان diagonally dominant وبنعرف إنه هالسيستم عادة have good characteristics يعني ما بيعطيني let's say divergent solution ساعتها بستعمل Gauss Seidel. Okay so بدي أكون متأكد إنه if I am sure that it's prone to divergence ساعتها yes Jacobi is better. Okay بس مش يعني اذا عطوا اذا diagonally non dominant يعني على طول جاكوبي احسن، لا، لانه مثل ما قلنا في يكون سيستم مش diagonally dominant بس يكون عنده good convergence properties ساعتها Gauss Seidel is better. Okay, next problem. Transform the following systems to become diagonally dominant. So always whenever if a system can be transformed to diagonally dominant the following condition should be. بشوف كل equation أي place لازم تكون. يعني in this equation عندي ال coefficient of z هو dominant لأنه 7 is larger than absolute value of 6 plus 0. So هيدي ال equation is good to put as which أي place. What is the convenient place for this equation? First, second, or third?
Third.
Third. Very good. This should be the third equation. I go to the second equation. It has the highest coefficient ما بكفي كمان يكون الhighest coefficient على diagonal. I should make sure إنه it's larger than the summation of absolute values of elements. يعني 8 larger than 3 plus 1. So هيدي لازم تكون بالfirst place. And the last equation إذا بتطلع بالlarger coefficient اللي هو 4 is larger than 2 plus the absolute value of -1 اللي هي 1. 4 is larger than 3. So this equation should be in the second place. هون ما عندي conflict. I don't have any conflict لأنه كل equation لازم تكون بمحل optimal different عن الثاني. يعني ما عندي repetition. الأول equation لازم تكون بالthird place. ثاني equation لازم تكون بالfirst place. And the third equation should be in the second place. So now
دكتور it is enough إنه بس طبق إنه الابسولوت فاليو هي أكبر من السم تبع الرو.
من السم تبع الابسوليوت values للاليمنت. yes.
بالرو بس. اوكي.
بالرو اكيد. اوكي. هلا here I can say how to have هيدي بالthird place وهيدي بالfirst place وهي بالsecond. The first transformation I should do is to pivot 1 and 3 فتصير لانه نحن قلنا انه هيدي لازم تكون بالthird place. So the first modification to do is to pivot 1 and 3. بيصير السيستم تبعي 2x. هلا فيني اعمل different I can do several strategies. يعني انا فيني بلش انه اعمل switch 1 and 3 برجع بعمل a second switch او فيني بلش to pivot 1 and 2. يعني اثنيناتهم صح. فيني يعني اثنيناتهم حيزبطوا بالاخر لانه if I pivot اذا قررت اعمل اول شيء pivoting 1 and 3 شو بصير عندي؟ بصير عندي 2x plus 4y minus g equals to 5. بس هالايكويشن بعدها مش in place. ثاني equation هي 8x كمان الثاني بعدها مش in place. يعني each pivoting will put one of the equations in its place plus z equal to 12. And the third relation هلا صارت ال third equation بمطرحها. يعني now I ensured انه ال minus 6 plus 7z صارت بمطرحها equals to 1. Now to continue my operation نحن قلنا انه this equation should be the first one and this equation should be the second. يعني now the second pivoting will be between 2 and 3. Between 2 and 3. Another possibility is to pivot first 1 and 2. If I pivot first 1 and 2 بتصير ال second equation بمحلها بس ال minus 6 plus 7z منا بعد بمحلها. So then I should pivot 2 and 3. So in overall I need 2 pivoting. فيني أعمل different pivoting but at the end this equation should be in the first place, this equation should be in the second place, and this equation should be in the third place. Okay. Now شو كان صار مثلا لو this element here بدل ما يكون -1 كان -5. Then I cannot do anything to make my system diagonally dominant. Why? لأنه هذه equation okay بتكون convenient يعني ما حتكون convenient ولا place. Why? لأنه أول شيء 2 منه أكبر من 4 plus 5 و4 منه أكبر من 2 plus 5 و5 منه أكبر من 4 plus 2. يعني هيدي الإيكويشن وين ما حطيتها مش ظابطة. Or also another possibility, let's say if I give you here 8 ساعتها بتزبط هيدي بس بدها تكون بالثيرد بليس. فتزبط لازم تكون بالثيرد بليس بس ما already أول equation كمان لازم تكون بالثيرد بليس. صار عندي 2 equations مفروض يكونوا بالثيرد place which is not possible. يعني this system cannot be transformed to a diagonally dominant system. And in majority of cases, we cannot transform it to a diagonally dominant system. So we should deal with it as it is. But we can try to do strategies. We can try to change the equation used for each variable. We can try to do under relaxation, etc. Okay. Okay. Now, it's another system. In this system, if we want to check if we can make it diagonally dominant, this equation, عندنا 4 is larger than 1 plus 1, and this should be in the second place. This equation 5 is larger than 1 plus 1. So this should be in the third place. And the last equation, the coefficient of x, 3, is larger than 1 plus 1. So it should be in the first place. No conflict here. So we just have to switch, do two switch operations to be able to get my system diagonally dominant. When I pivot, for example, 1 and 2 first, then 2 and 3, I will end up with a diagonally dominant system. Yes, of course, you should mention the rows you pivot, okay? You should say, I will pivot the following rows, then pivot these rows to come up with the final system. You should say what you did to transform, okay?
دكتور كيف بدي احطه هاي على البلاك بورد اذا اجى هيك سؤال؟
خليها علي يا ساج، ماذا تفهم؟ أنا بعطيك، يمكن بقول لك إنه give me let's say what for the third equation مثلا what is the B element، يعني بسألك على شيء معين، ما حأطلب منك فوت السيستم كله.
اوكي.
على طول في number، يعني بالبروبلمز كلهم حيكونوا بطريقة you need to give a number at the end. أو فيني أسألك عنه بالtrue or false، يعني to test إنه you understood what is diagonally dominant، okay؟ إذا ما إجا بالproblems. لأنه you know بالنهاية I cannot put 100، يعني في 100 ideas that we can test here، بس إنه I have 3 problems، يعني ما هذا I cannot cover all ideas. This is why I do true or false. In true or false, you have all ideas involved about all methods. Problem 5. Using multivariate Newton-Raphson method, solve for the following system and use as initial guesses x equals y equals 1.2. So you have this following system, minus x squared plus x minus y equals to minus 0.5, and x squared minus y equals to 5xy. And you want to solve these equations. So remember always when you have such system with multiple variables, you should transform the system to a system of equations equals to 0. So you will take first minus 0.5 to this side, and you will define function 1, which is a function of x and y, as minus x squared plus x plus 0.5 minus 1. And here also you will take this term to the other side, and you define a second function of 2xy equals to x squared minus y minus 7 minus 5xy. And your system will consist of solving these two equations equal to 0. So you know that we have developed together in the course material how to solve multivariate using multivariate Newton-Raphson method such systems. All we have to do is first to find the Jacobian terms. So we should derive these functions with respect to their variables. So first we do the partial derivative. F1 is function of x and y. So the first element of our Jacobian will be del F1 by del x at state 0. So you will iterate. We'll first use the initial guess. So we have an initial guess for x and y here equals to 1.2. So to start with, when I derive with respect to x, I consider that y is a constant. So this term is constant. So when deriving with respect to x, I have minus 2x plus 1. And then I replace x by the initial guess. I can get del F1 over del x at stage 0 for the 0th iteration. Now, second, I will derive del F1 with respect to the second variable, which is y. So whenever I derive with respect to y, I consider that x is a constant. So these terms are constant and their derivative is 0. So when deriving with respect to y, I just have minus 1. This is why del F1 over del y is equal to minus 1. And then I move to the second function. I do the partial derivative first with respect to x. Y is a constant. I have x squared derivative is 2x. And minus 5xy derivative is minus 5y, since y is considered as a constant. So the second derivative, the derivative of f with respect, partial derivative of f2 with respect to x is 2x minus 5y. So to compute the initial value of it, all I have to do is to replace by the initial guess x equals 1.2 and y equals 1.2. And finally, I need to compute the partial derivative of f2 with respect to y. So I consider that x squared is a constant. So minus 1 is the minus y derivative is minus 1, and minus 5xy derivative is minus 5x, which is a constant considered as constant. So now I have obtained the general forms of elements of my Jacobian. All I have to do is to evaluate these terms first at the initial gas. Once I evaluate them at the initial gas, I should also evaluate the function values of 1 f2 at the initial gas. So I replace x and y by 1.2. I can get f1 0 and f2 0. Once this is done, I use the Newton-Raphson formulation for multiple variables, and this will help me to update values of f1 and f2, of x1 and x2, sorry. So now after computing the Jacobian terms and computing the function terms, I replace into Newton-Raphson formulation. So I get the updated values of x1 and x2. This will be the values of x if you want here it's x1, x2, or xy if you want, because here the variables are called x and y. So this is x at first iteration, this is y at first iteration, okay? And now these values will constitute the new values that will be used in next step, okay? So I will continue to iterate, and you can see here the iterations done. In this problem, the given was missing. Okay, I expected that you ask me what is the criterion. So here we should specify, for example, we should say use 4 iterations or use a stopping criterion of 2%. Because if they don't tell you what to do, you cannot know where to stop. Okay, so here we will perform 4 iterations, and the results are summarized in the following table, so you can make sure of your calculations. This is x0, y0, this is x1, y1, etc. You will continue to proceed. For example, if the criterion of convergence was to have approximate relative error lower than 1%, you can stop here. You can stop at the 3rd iteration. In case you want to have a more stricter criterion, let's say of 0.1%, you should proceed to the 4th iteration. And here they can just tell you perform 4 iterations. So depending on the given, you will know where to stop. Okay? Any question on this problem?
دكتور انا بدي اسالك كرمال نطلع الاكس والواي ضروري
Yes.
نحطهم بماتريكس فيها جي تايمز اكس ايكوال لبي.
انت بتحط لي الماتريكس بس تعمل كالكوليشن على الكالكوليتر. يعني انا ما بدي اياك تستعمل تكنيكس الا اذا طلبت منك يوز مثلا جاكوبي او يوز جوس سايدل تو سولف فور x1 x2. بس عاده بس جيب لك هيك ميثود you can solve it بالكالكوليتر. يعني بس بدي اعرف انت يعني انت you should show at each step what is the calculated del f and what is the calculated f. And then you can substitute just in the formula directly with calculator and give me the updated values of x and y. Okay?
ودكتور
يعني أنا بيهمني تفرجيني هول الفاليوز. مفروض على كل ستيب تفرجيني شو هن الاليمنتس تبع الجاكوبيان، لأنه بلاهم ما فيك تعمل calculation. You should show me the updated values of f على البوينتس, and then you can just put يعني انت اذا عندك iterations اعمل وحده detailed والباقيين بس حط الفاليو انه شو هي ده الاف باي ده الاكس. اصلا انا ما حجيب لك كثير iteration، بجيب شي 2 iterations. يعني احسن تكتبهم detailed هيك اذا عندك غلط I can track your error.
يس. ودكتور في حال طلبت مننا مثلا نحلها بجوس سايدل بتقولي لنا امتى بدنا نوقف؟
اكيد I will tell you of course.
Thank you دكتور.
Okay. Now, in problem 6, find the line of best fit for the following data representing the variation of the gravitational constant in meter per second square with altitude in meter. Then give an estimation of the value of G for an altitude of 55,000 meters. So here they mentioned which type of fit you should do. You should do a linear fit. Okay. And please, as I mentioned yesterday in the session, whenever they give you a method developed in class, you can use it directly. But if they ask for a fit that was not developed in class, you should do the complete derivation. And Anna, this time I will be more clear. I will tell you derive, then give me a result. Okay? So here, since the linear fit was developed in class, all you have to do is to go to your notes, and from your notes, you know that coefficients A0 and A1 are given by the following. So to calculate A0 and A1, what should I know? I should know the number of points, data points used. I should know what is summation of xi square, what is summation of y, what is summation of xy, and when I have all of these, I can calculate my A0 and A1. Okay, so now all I have to do then is to go back to my problem and say I will add some columns in order to have all required data. So already I have xi and yi, so I do their summation. This is summation of xi, this is summation of yi. I need also to compute xi square and xi yi, so I compute all elements and I find their summations. I advise you to put a table so I can track your errors. Because if you just give me the value, I cannot put partial grades. So please, ما حيكونوا الداتا كتار عليكم. I will not put a lot of data for you. So do put it in table and show your calculation so that you can gain the maximum of partial grades. So now, once you have all of these informations, it's enough for you. All you have to do is to replace an expression of A1, A0 developed in the course material. Okay? And n here is equal to the number of points, so n is equal to 5. And now I have all summations needed. So you have that A1 is equal to n, which is 5, times sum of xi, yi, which is here, minus sum of xi times sum of yi, okay, over n times xi square, which is here, minus the summation of xi square. So all you have to do now is just to replace in these formulas, and then you can get A1. Similarly for A0, to get A0, you replace in the formula, which is sum of yi over n minus the value of A1 you got from here, okay, times this term, which is sum of xi over n, and then you get A0, okay. And once you have A0 and A1, then you can say that the linear function is of the form, my variable y here represents the gravitational acceleration g. I have that y represents the altitude. So now if they give me any altitude y, I can just replace here and find the corresponding value of g, of the gravitational acceleration. This is why they asked me to perform an estimation for g for an altitude of 55,000. So now you can expect that if you replace y by 55,000, if you didn't do any calculation error, you should have a value for g between these two because it's a linear fit. If the value you obtain is outside of this interval, this means that you have a certain calculation error somewhere. So here, as expected, you will get a value of 9.643, etc. So my computation seems to be right. Okay. Any question on this problem? Okay. Now, problem 7. The following data can be modeled by a function of the following form. Y equals to alpha 4 times x times exponential beta 4x. Linearize the data and then find values of alpha 4 and beta 4. Plot the corresponding data and the fit for both linear and model fits. So here, it's not 100% similar to what we have seen in class. So whenever you have something new, try to think about it. No need to have always same forms of what we have in class. أنا كان بدي أعطيكم هذا الإكزام بس قلت حرام يمكن ما تعرفوا تعملوه. But it's not complex. All you have to do في كتير سألونا إنه it's not working with us. you should try to do some transformation to make it in the linear form you know. يعني أنا شو زعجني بهالإيكويشن جديد عند الإكس. This x is not familiar for me. I am used to have y equal alpha times exponential beta x. I do ln both sides بتصير linear. طب هلا if I do ln both sides as it is, I will not get a linear function. No, I will get the following. I will get ln y equals to ln alpha 4 plus ln x plus ln beta 4x. Ln exponential beta 4x. So ln and exponential will cancel out. So plus beta 4x. What is preventing my function to be of a linear form is this term, ln of x. Because it's not a constant term. This is a linear term, beta 4 times x. This is a constant, it's fine. But this term is not good for me. So what can I do? All I have to do is take it to the other side. If I take it to the other side, I get ln y minus ln x. I can write it in the following form. I can write it ln y over x equals to ln alpha 4 plus beta 4 times x. And now it's linear. So all you have to do is to do some transformation, okay, so that you get a linear system. So now what will be your change of variables? So here you have n. You will say, I will consider variable big Y as ln y over x. I will consider big X equals to small x. And what will be my ln alpha 4 will represent my coefficient A0. And A1 will be equal to beta 4. Okay? So now, when I solve for A0, A1 using linear fit, when I am done, I can go back to find beta 4 and alpha 4. Because A1 will be exactly equal to beta 4. And alpha 4 can be written as exponential of A0. So once I do the linear fit, I can use the coefficients of the linear fit to find my alpha 4, beta 4, so that I can draw my following function, which is not linear, which is an exponential profile times x. Okay, so now the first step to do is to linearize my data. When I linearize my data, I do the change of variable. My variables will be now x and ln y over x. From this data, I will come up with coefficients A0 and A1, exactly as I did in the previous problem. When I do so, I come up with my coefficients. So this is A1. And we said already that A1 is equal to beta 4. So beta 4 is equal to minus 2.4733. And alpha 4 is exponential of A0. So it's exponential of 2.2682. And now once I have beta 4 and alpha 4, I know the exact form of my function. So y is, I replace alpha 4 by 9.661786 times x times exponential of beta 4, which is minus 2.4733 times x. And now I can plot data both in as linear and as the actual function. If I want to plot the linear data, I just plot ln y over x, the data of ln y over x, in terms of small x. Okay? And if I want to present now the actual function, I will use the following formula with the data. So with data yi xi, while here I will use data xi and ln yi over xi. So now the next graph I can do is to plot the actual function and the actual data without linearization. And also I predict to have a good fit because the linear fit was performing well. So of course, since my coefficients alpha 4 and beta 4 are deduced from the linear coefficients, so I expect also here to have a good fit. Okay? Any question on this problem? Okay. Now, another problem, find the best quadratic fit for the following data, representing the variation of a force with respect to velocity of air, and plot the resulting fit with data points. So again, I repeat, whenever I give you a type of fit that is already described in the course material, you directly use the result. So now you will have to go to chapter 15. In chapter 15, we have developed together coefficients for a cubic least squares fit expression matrix, and we have developed the general matrix that will be used, the system A times X equal B, that will be used to solve for the coefficient. We have done this for a cubic fit, and we have done this for a quadratic fit. If I ask you any type of higher order fit, okay, you should do the derivation. And you should go back to the expression of sum of residuals, then derive it with respect to the different coefficients, and find the general expression of the matrix. Okay. Here, since it was developed in class, I can look at it and see what are the summation I need to get A0, A1, and A2. I need sum of xi, I need sum of xi squared, I need sum of xi cubed, I need sum of xi to the power 4, I need sum of yi, I need sum of xi yi, and sum of xi square yi. So now I go to my table here. I go to my table, I put all columns needed, which are sum of x. So x and y are already present. All I have to do is to compute the summation. And I add to my table all columns needed, x squared, x z, x to the power 4, x times y, and x squared y. And then I compute their summations. And now all I have to do is to replace in the matrix, the general matrix we developed together. So the first element is n, which is the number of data points, which is 8 here. So the first element of the first row is 8. The second element was proved to be sum of xi, I replace it. The third element is sum of xi squared, I replace it. Now for the second row, I start with sum of xi. The second term is sum of xi squared. The third term is sum of xi cubed. While the third equation will start with sum of xi squared, then sum of xi cubed, then sum of xi to the power 4. And finally, the B vector here is constituted by the first element is sum of yi, the second element is sum of x times y, and the third element is sum of x squared y. Once I am done with this system, I will read well the question. What did they ask me for? And I should read well the question before filling this data. يمكن بس يطلبوا منكم, let's say, what is summation of elements of the second row of the matrix of coefficients? So just you calculate these coefficients and you sum them. So you write first the general form, but you just use what you need to find. Okay? Here, if they ask you to solve the system, or they will tell you to use the calculator, it's a system of 3 equations with 3 unknown to get A0, A1, A2. Or they can ask you for a specific coefficient. Let's say solve for A0, but of course to solve for A0, if you are using, let's say, Gauss-Seidel or Jacobi, you should solve for O. But you should continue to perform iterations until reaching the satisfying criterion. Our number of iteration, our stopping criterion epsilon. Okay. So that's it. So read well the question to know what they want you to do. And once you are done, once you get A0, A1, A2, this is your formula. F is minus 178.4821 plus 16.12202V plus 0.037202V squared. As you can see here, you can suggest that a linear fit will work well because the coefficient of V squared is much smaller compared to the coefficient of V. So I get nearly a linear behavior. So if you draw the profile, it's close to linear because the coefficient of square was small compared to the coefficient of V to the power 1. Okay. And this is your graph. You plotted your function with the data points, and it seems that it's a good fit. If they ask you to calculate the sum of residual SR, how you do it? It's very simple. Once you find the fit, you go back to the definition. What is SR? SR is summation from I going from 1 to n of y fit at I minus yi square. Okay, so if they tell you to calculate the error resulting from least square regression, you can just, once you find your equation of fit, you say I will calculate at each data point xi what is y fit from the equation I got, and then I do y fit I minus yi square for each point, and then I do their summations for all data points to get the value of SR. And this is the minimum possible error. This equation will ensure that this is the minimum possible error using this square regression that I can have. If I select any other quadratic line, quadratic function, I will result in higher error. Okay? Any question on this problem?
دكتور أنا
Yeah.
بدي أسأل إذا كان أكتر من كيوبيك فينا دغري نستعمل فكرة إنه الماتريكس إلها باترن مثل ما إنه أول
Okay.
كولم بيكون الرو ماينس 1 وهيك ولا بدنا نفرجيك الإيكويشنز؟
هلا امال اذا بقول لي يعني it's better to derive. انا حقلكم هالمره فما تكون confusing، حقلكم derive. اوكي
أوكي
اوكي
Thank
هلا
you.
لانه sometimes you can generalize the pattern, sometimes no. sometimes مش دغري بيبين الباترن واضح كيف الا ما تكتب الايكويشن. هون ثاقبت لانه عملنا انا وياكم عملنا two cases، الكيوبيك والكوادراتيك، صار عندنا فكره كيف حيكون الباترن. مشان هيك قلنا انه it seems انه قبل كان عندنا this matrix، وقت عملنا كيوبيك فيت زدنا هول الاليمنتس، يعني هالباترن صار واضح بالنسبه لنا. انه هلا اذا بدنا نزيد كوارتيك فيت حيكون sum of xi هون 4، هون حيكون summation of xi to the power 5، هون حيكون summation xi to the power 6، هون 7 and we need a fifth row لانه في it's a symmetric matrix لانه transpose is equal to the matrix. so فينا نستنتج انه اخر row حتكون summation of x4، هون summation of x5، هون summation of x6، هون of 7 and the final term is summation of x to the power 8. and here كان عندنا some yi some xi yi some xi square yi بقبل. وقت عملنا كيوبيك فيت صار زاد عنا some x cube yi، يعني we can conclude انه حيكون now some xi 4 yi. بس sometimes مثل ما قلت لكم لانه هون already عملنا two iterations we're able to generalize. بس اذا اعطيتكم case مش معمول okay you should do the derivation.
Okay, thank you.
Welcome. Any other question?
في number 9 و 10.
هلا tomorrow we'll go over them. Okay.
Yeah,
And of
yeah,
course, if you
بعطيك
have
يوم.
any questions, you can prepare them for tomorrow. After finishing the correction of the homework, I can answer all your questions.
دكتور في ابعت لك نمبر 9 و 10 على الواتساب. انا عملت سبميت الهوم بس لنمبر 8 لانه ما له حل.
It's fine. It's fine.
Thank you, doctor.
Okay.
Thank you, Doc. Thank you, Doctor. Goodbye.
Welcome. Bye.